Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by B2B Energy. My name is Paul Webb, and I'm the founder of B2B Energy, and I'm your host. And weekly, I present to you energy experts from around the world. Welcome to episode 140. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. We would like to thank utility people who are creating a better career and future for people in our industry. Welcome, energy enthusiasts, to another enlightening episode of Energy Speaks Back. Today's guest is an energy expert from France who has the passion to take nuclear power across to his home country. So without any further ado, let's dive into the conversation with Mario Alessandro Pelino. Good evening, Mario. How are you today?
I'm doing just great, Paul. Thank you for having me.
Brilliant. We're really looking forward to this because when I looked at your LinkedIn profile, I see the magic word in my mind because obviously that's where I come from, and the word was nuclear. So I'm hoping we're going to touch on that subject today. So we've just met. We've just had a little bit of off-air conversation, which is brilliant. It's really nice to meet you. Thank you for reaching out to us and joining us today. So for the benefit of me and for our audience today, can you give us some background to your origin story and how you've come into this industry?
Of course. Thank you, Paul. First of all, I think I could say I'm from Honduras, Central America, and I've been living in France for 10 years now. So
Right.
time has been flying by.
Can
And I
imagine.
came for my studies in university, and I came with the idea of having just a physics degree because of my, curious mind, practical mind, trying to understand pretty much the universe. And, year after year, you get an idea of what you actually want to do.
Hmm.
And energy started to be a topic that we could see around in the news. And it was an actual topic in Honduras also. So you know that around the world, there's not the same level of electrification. And when you're having blackouts at your house three
Yeah.
or four times a week, that just uh, asks you questions. You
Hmm.
start asking questions. And so those questions I started getting answers to in university. And since I was in France, I decided to specialize in my master's degree on nuclear power. It's a great science topic. You can go deep down into some mathematical models, which for curious minds can be of a lot of gratification.
Hmm.
And so since then, since 2019, I've been working for the nuclear industry in France. I also headed to Belgium for a couple of months to work with Engie, and now I'm a nuclear trainer for businesses and for students in university. So
Brilliant.
that sums it up pretty much.
That does indeed. And is there nuclear power back in Honduras?
Not yet, but it's a subject that I'm actually trying to push uh,
Right.
every time I go back, so once or twice a year, and I'm trying to meet with the scientists in our countries because there are some guidelines that can be used from the International Agency of Atomic Energy, and for countries that want to
Hmm.
develop it. So that's why I say not yet, one day.
Right. So there is a pathway for other countries to explore this route.
Totally, totally. And since nuclear has been identified as a key strategic production mode, countries are getting more and more interested. You can
Hmm.
see as an example China, which now has 55 nuclear reactors in operation. Even though it's the greatest uh, CO2 emitter around the
Yeah.
world. It is also putting some investment, not only monetary investment, but I'm talking about students going around the world. As a teacher, I see Chinese students in
Right.
French master's degrees. And so there's a strategy from worldwide for countries getting into nuclear and just, numbers talk. Right now, France has 56 nuclear reactors that are operable. China has already 55. So it's catching up to one of the world nuclear leaders.
Yeah. Is France coming to some of their end of the curve regarding some of their nuclear power stations because of, they were many years. Obviously, everyone knows that I was in the nuclear industry. When I was in the nuclear industry, the French had more nuclear power stations than the UK,
That's
and
a
so they headed out quite because they haven't got no resource, have they?
That's a great question, Paul. And actually, it's the key, to our current situation in France. Just to give you some numbers, right now the average age of reactors is pretty much around 30 years.
Right.
They are conceived for 40, even though it's not stated in the law.
Yeah.
But still, right now EDF, the main company, is working on some great maintenance to have their 900 megawatts reactors go to at least 50 to 60 years of operation. And around
Wow.
the world, it's pretty much the same. We
Yeah.
have, I have some numbers here: nuclear reactors by average age. 0 to 10, you have 71 reactors. 11 to 20, you have 30 reactors. 21 to 30, you have 41. And this is the shocking number: 31 to 40 years of age, you have 154 reactors around the world.
Wow.
So, the average is around 30 years of age, which just speaks about the energy strategy that countries have been having
Yeah.
since pretty much the 80s. The nuclear capacity has not gone up.
Yeah. So I was an apprentice at Bradwell Nuclear Power. I wasn't allowed to go there until I was 18 because that's the nuclear regulations.
Mhm.
And so are we saying now that possibly because of all the new safety and the new maintenance that could be carried out, if we wound the clock back, we could have probably extended the time of that power station, possibly?
Yeah. Yes, what I use to illustrate this is, you can think about it as a car. Let's say your car was built to last for 40 years, but
Yeah.
does that mean that your car at 40 years and one day will just stop working?
No.
No, it's not the case, and it's the same for other industrial systems. As long as you take good care of it and you have high standards of maintenance and safety, you could let it run for another couple of years.
Yeah. Do you know, you're smart about this, but this is one of the reasons why I left nuclear power because we're two reactors and every year we swap the maintenance. So one year we'd maintain reactor one, the following year reactor two. And I was getting frustrated to do the same maintenance every year on the same or a different reactor. It was just, do I go into the building and turn left or do I go into the building and turn right? You know, reactor one and reactor two. And that was really one of my, I wanted to learn more. I wanted, like yourself, you want to have inquisitive minds. So as an engineer, I'd done all my training to become an engineer, but I thought, what's next? What's next? I can't keep. And sometimes you would look at that, you'll be doing the bolts up or undoing the bolts, and you think, deja vu. I've done this one before. That's one of the reasons why. And I know then that safety was paramount, unbelievable safety regulations, the maintenance that we carried out. And I'm going to refer, you may not get this joke, but there used to be a comedy program. It used to be called Triggers. He come up with this thing about Triggers broom. Okay. You imagine a broom. This
Mhm.
broom lasted him for 30 years, but he had changed five lots of heads and five lots of sticks. So think about this car. If you want to take it to the next level, you change the whole engine, you change the doors or whatever. So the whole, when you look at that reactor, the parts weren't 30, 40 years old, were they? Because you probably replaced them many times.
Yeah, pretty much the only part that you cannot replace is the core. That's where the
Yeah,
fusion is going
yeah.
on. On the rest of them, the steam generator you can replace,
Oh,
valves you can replace,
exactly.
circuits you can replace them.
Yeah. And I know that you know, the important thing here is health and safety and the actual safety of that. Maybe they're the decisions that will override the maintenance, and that side of it. I'm interested to know. So the French used PWR, didn't they? Pressurized water reactors. Um, did they have any Magnox?
Sorry.
Any Magnox reactors? Because where I was Magnox,
Mhm. So it's PWR reactors pretty much.
right?
That's the standard since the 1970s. So they
Right.
started out with some natural uranium, so
Yeah.
U-34, using graphite and carbon.
Hmm.
And then pretty much the Westinghouse technology was adopted in France, and now you have, 56 operators, nuclear reactors operating
Right.
around France, 900 megawatts, 1300 megawatts, 1400 megawatts, and the newest one that is being built, uh, 1650 megawatts. Talking about electric, of course,
Yeah.
output.
Have you got any opinion about the contamination and radiation of, say, items that then we have to store somewhere? Because that's one of the drawbacks of, you have this fuel becomes spent fuel. We then have to take that out. It has to be cooled down, and then we slowly transfer that to another area for recycling. Do you have any personal opinion about that? What we have to do with that?
Yeah, of course, that's the main fear of the public. So it's a question that has to be asked. And the first thing is to understand what are the radioactive products that you get from a nuclear power plant. So pretty much you can divide them in terms of how radioactive they are
Hmm.
and for how long are they going to stay radioactive. So the 90% of the volume of those that have low radioactivity, constitutes the volume. So 90% have low radioactivity, and it
Right.
corresponds to around 0.1%.
Hmm.
And the rest of the volume, has it has high radioactivity. So 99.9 of the radioactivity is condensed in pretty much 10% of the whole volume. So after you have those numbers, you have to ask yourself, okay, so how do I treat this 90% volume that has low radioactivity? And what do I do with the rest?
Hmm.
And of course, France has been really smart on how it organized its industry, because they go from extracting the uranium to putting it in operable reactors to doing the recycling of it. So they have really good knowledge about how to treat, the in the whole cycle of uranium. So pretty much at the end of the cycle, where you have to deal with this low radioactivity or high radioactivity, you have different strategies.
Hmm.
For the high radioactivity, which are going to last for long, long, long periods, or not going to be around when they are still radioactive. They put it in metal containments and with some other barriers. If we have to go to technical details, we could spend a whole
Yeah.
other
Yeah.
month and a
But
whole other
we
day
just
around
let's
it.
just take it that has to happen. Yeah.
That totally has to happen.
Yeah.
It's the mo it to answer the public's fears. You have to actually inform them of how it's done,
Mm.
illustrate it,
Yeah.
explain it with, even if it is with technical words, tell them, okay, this is how we're going to treat this part, this volume of it. But first, people don't even know that there are different types of radioactive waste.
Yeah.
And so that's the
Well,
most
working
important.
in the power station, clothing. So certain clothing, when we've been reactor
Mhm.
side, that has to be washed. But then some
Yep.
certain tools and things, even tape, we would take that off, and that would go into a red bin, and then that would be obviously the afterlives of that would be less because obviously it's not like it's been really it hasn't been radiated, it's just been contaminated as such. So there's a difference between contamination and radiation.
Exactly, exactly. And
So have you worked in a nuclear power station and been sort of
I've been
reactor side?
I've only been on the engineering side of it. I've done some visits of the Goldfish nuclear power plant, which
Right.
is right next to Toulouse, which is
Right.
the city where I live in France. So it's a beautiful nuclear power plant, which produces pretty much in 2022. It produced with its nuclear reactor the equivalent electricity consumption of 2.3 million families. So
Wow.
yeah, yeah, yeah.
That's a big
That's
chunk
the
of,
output that you get from
yeah,
from the nuclear power plants.
yeah.
So
So Bradwell Nuclear Power Station used to cover basically the whole of South Essex. So where I live, and the
wow.
transmission
Mhm.
lines are still there today, but they're not. Sadly, they're not being used, which is a shame, really, because you've got all that infrastructure there. Um, so they should have really put another power station there because they already had the infrastructure ready for it, train line to take the flask out and things.
Well, Paul, you mentioned a really interesting point. When you have to build a nuclear power plant, you just don't build a nuclear power plant if
No,
you don't build the infrastructure. And effectively, that's one of the interesting parts.
mm,
When I was talking about Honduras and its problems and introducing nuclear power to it, it's not going to be an easy task.
no,
First, have to train your people to be electricians, to know about civil engineering, to have, just a whole spectrum of knowledge, of technical knowledge.
mm,
And that's what's interesting in this industry, is that you don't only have physicists and nuclear engineers working on it. You have chemists, you have civil engineers, you have
yeah.
industrial engineers, you have electricians, you have a whole
Even
spectrum of
even
domains.
down to laborers. So we had laborers there cleaning, cleaning the non-nuclear side, cleaning the nuclear side, health and physics, canteen staff,
Exactly.
works office, designers. Do you know what? It was like a city on its own. Absolutely amazing. And I could not believe it. I've been back. I put a post up a couple of years ago. All is left now is just the reactors in these shells. Everything's just been taken away.
Taken away. Yeah.
All the workshops, all the security areas, all the canteens. It's just in my world. It's criminal because it's my memories. I done my apprenticeship there. So when so I worked for the CAGB. When you're doing an apprenticeship with the CAGB, you have to spend time and do everything. So I worked with the labourers team. I worked with the operators. So I operated non-nuclear and nuclear. And I was even telling someone the other day that I used to uh, raise the rods up and down to increase the power and things. We used to do
Wow.
that manually. It was quite an old power station. Um, I've actually fueled the with the because nuclear fuel when it comes in, for the benefit of the audience, it
Mm-hmm.
isn't radio, it's not radioactive. So
Mm.
basically, you've got uranium in your hands. Obviously, you've got gloves on and things, but you put it in like it's like a comes in like a missile, and you put it
Yeah.
in the. You have to load it like a magazine. The stuff I learned was unbelievable, and I think I own it. Then, lastly, I worked with the ops team where we took the fuel out. Obviously, it was highly radioactive. We had to be
Yes.
careful because sometimes it catches fire. Um, and then I like this one because we used to do a night shift. There's this massive swimming pool, and the swimming pool must be about 25 foot deep.
Mm-hmm.
But what we used to do is turn the lights off at night because in all the nuclear fuel used to glow down there because it was through the blue, and so we used to love watching that. We used to get told off by our managers and things because they used. Yeah, it's a shame we didn't have mobile phones in them days because I'd love to take loads of photographs of that. But anyway, so we used to turn them off, and then we used to. So you can't transfer the fuel. You have to take all the fins off. So you had to go
Mm.
through a splitter where to split them. So the rods was just left, the fuel cartridge as such. Then it had to go into a flask. Then we had to do the flask up, and then I was on the
Mm.
lorry. I took the lorry to part of my training. I had to go with the driver. We had to take that and put that on the back of a train to go up to Sellafield.
That's such a great experience that you had. What
Oh,
what
I've only just touched it. There's loads of other things we did as well. It's brilliant. I loved it.
and you also this I'm guessing this was when you were 17, you said?
So it's when I left school. I was working for the nuclear for the CGB, but it was from the age of 18.
Wow. And you mentioned you used a lot of technical words. So for the audience, like the blue light and and the roads where the uranium comes, and this is the great thing that once you start working on the nuclear power plants, you get to have a lot of experience,
Yeah.
and it's very different from other industries. It has a lot of particular things to it. This blue light you're talking to, the Cherenkov effect, is
Yeah.
something really amazing to look. And just for the benefit of the audience, I'm just gonna give like a fun fact about the energy density of uranium.
Hmm.
So, you said that it came in like a missile form. Of It's not a missile, but
Yeah. 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 Yeah.
it does
It's the
come in
best
this
way to
kind of
describe it.
way, of course. But it it's also composed of little parts of uranium, like pills, let's call it like that.
Hmm.
And each pill is pretty much between 7 or 8 grams of uranium. And the energy density that you get from those 7 to 8 grams is the equivalent to about 1 ton of carbon.
Yeah.
So that's the difference, between the combustion, so chemical energy that you get from coal, and the fission, which is really the nuclear energy coming from the atoms. So
Mm.
that's just a fun fact to throw out there for the audience.
The the other thing, so to move the heat across the fuel, obviously you use boron to like a you use a carbon to slow the fuel down.
Mm,
So you put that in, or you put it up to speed it up. So
yeah.
obviously it starts reacting. But the interesting thing, so that's carbon we used to control the nuclear sort of reaction, and we also threw we blew CO2 gas
Mm.
across the fuel because and you know why we you stupid question, you know that. So we blew the CO2 gas across, and for the benefit of the audience, the reason why they do that is because CO2 gas does not get contaminated. It doesn't get contracted with the nuclear radiation or contaminated. So basically, the fuel just to go, it's the best transfer. So you used to transfer the heat, and then bring it back again, and it would be clean still.
Exactly.
So
It's a
that
good way
the
to
the the,
evacuate
um,
all the
the
megawatt.
physics that have gone into nuclear power is unbelievable. I think
I
really
totally agree with you.
there's a lot of thought gone into it, isn't there?
Totally. And when a country goes into nuclear, they don't just go and and do it. They
Yeah.
have to have a strategy. Let me tell you, as a trainer, for instance, right now, nuclear in France is just being restarted pretty much. The industry had not a lot of hopes. The Fessenheim nuclear power plants were shut, nuclear reactors were shut down, and a couple of years later, you have this new boom where they say, yes, we are now going to build new nuclear power plants.
Right.
And with that has to come university diplomas that have to be
Hmm.
developed. You have to have technical diplomas that have to be developed. We were talking about that labor that you need. The workforce is tremendous for every single reactor. There are at least 1,000 people working for it. So you have to have um, a strategy, a global strategy to develop this kind of industry.
What about the timing of all this though? Because it takes a long time to go from, we're going to get planning permission to put a nuclear power station here, to actually build the power station and to get it right takes a significant amount of time, doesn't it?
Totally, and that's that's actually why for me it's so interesting to be, at the heart of the education of people,
Hmm.
to see how many people are getting interested in it, because it depends on the workforce that you're going to have, how much time it is going to take. Even if you want to build your nuclear power plant in 5, 6 years, if you do not have the workforce, if you do not have people interested in it, if people just go for 1 year and just leave, you
Yeah.
know, there has to be a workforce. There has to be good project management for this to happen in before, let's say, 2050, which is the year that France is aiming, to be net uh,
Net
net
zero.
carbon.
Yeah.
Net zero, yeah.
Yeah. Um, well, I, I listened to Bill Gates. He talks about sustainability going forward,
Yeah.
and he was saying that there are developments for what they call micro nuclear power stations. Have you come across that?
Yeah, so currently, what you're talking about is small modular reactors.
Hmm.
So it's not when you hear the acronym is SMR, right?
Right.
Or XSMR. So the S is for small and actually standardized
Right.
modular reactor. It's to build it to just bring like the Lego parts together, and also for the dismantling of it, it will be easier.
Yeah.
So that's the first thing when you think about modular. And then small, that means that you're going to decentralize the production. You're going to go to parts of countries where you wouldn't put a 1600 megawatt reactor.
Yeah.
So the infrastructure, the electrical infrastructure that you're going to need is not going to be the same. And right now around the world, there are around, 80 designs for SMRs,
Right.
those currently that are in the design phase, some are on the construction phase. There
Hmm.
are two that are operable. But just to tell you, an event I went to in Paris in November of last year. So the WNE, World Nuclear Exhibition, where the whole nuclear industry is invited by the, uh, how would I pronounce? Let's pronounce this in French. The GIFEN, uh, group of industrial actors, of French industrial actors. And there was a lot of businesses that were getting into SMRs, and they were there to present the designs. There were also piece manufacturers that were there to present how they were going to adapt to those SMRs. So it's a thing, and
Yeah.
also for countries getting into nuclear, I think it will be easier to build a 200 megawatt reactor rather than a 1600 megawatt
Yeah. Yeah.
reactor.
Yeah.
Two different things, definitely.
So working in this industry, I'm going to test your propaganda approach really and how you would deal with the outside world. So
Yeah,
if I mention to you Chernobyl and the disaster that happened there, you know, impacted the on a big part of the country and the local people, what would you say? How do we stop things like that from happening again?
of course. So there are three major accidents to look at in the nuclear industry. The first one happened in the United States in the
Hmm.
70s, 3 Mile Island. Then some couple of years later, we were hit in Chernobyl, so a Ukrainian reactor.
Yeah.
That's the most disastrous one, actually.
Yeah.
And then we have the Fukushima case in 2011. So when you look at technologies, first you have a PWR, so pressurized water reactor in 3 Mile Island. Then in Chernobyl, you have an RMBK reactor.
Hmm.
And then in Fukushima, you have an REB reactor. I think that's the acronym in French, but
Yeah. Yeah.
let's go with that.
Yeah.
So the RBMK used in Chernobyl, the first thing that we have to say is that it's not the most stable technology. So that's one of the things that we learned. It doesn't have it has a positive coefficient for reactivity, which means that when temperature goes up, reactivity goes up,
Right.
and that's not the same thing that happens for PWR. So what do we take from Chernobyl, as every industry that has accidents has to take, um, feedback.
Yeah.
So what we take from that, first of all, is the transparency. We're in the URSS, so we didn't have a lot of transparency of what was going on. The respect of instructions was not done accordingly to how it's planned, and also there was no third confinement barrier, which French nuclear reactors are equipped with,
Right.
or 3 Mile Island was equipped with. So that's the thing we can learn from Chernobyl. In 3 Mile Island, what we can learn is the sequential approach that we had to accidents. So what happened there is, a combination of different system failures and maintenance errors that we had. And what operators had to do back then was imagine, okay, so if pressure is going down here, I think this is happening. So they had to had a mental idea of what was going on the reactor,
Yeah.
you
Yeah.
know. And of course, where there's a human, there's human error and
Exactly.
human error of interpretation. So from 3 Mile Island, that's the greatest feedback of what
Yeah.
we can. And then from Fukushima, what we can get is, first, that we have to have um, a lot more, be more careful at the conception level. They weren't ready for the tsunami, so when there was the earthquake, everything was fine. There was the nuclear shutdown, the reaction shut down. But then the tsunami was what caused the total loss of energy, and that was an accident sequence that was not studied thoroughly. And that's what we can get pretty much. To summarize
Yeah.
what we can get from all of three major nuclear accidents. Of course, we can go into deep detail of what other aspects we can get from
Yeah. Yeah.
feedback.
Yeah.
But it's really important that every industry adapts, to
We learn
when
from our
there's
mistakes.
an accident. As the same as the aviation industry, the same as the car industry, the same as the oil industry, they all
Mm,
have to adapt when there's a fire, when there's a crash, when
yeah,
there are so many industrial accidents that are possible. The most important thing is to get some feedback on every single accident so you prevent
yeah.
its occurrence in the future.
And rest assured, that's what the nuclear industry has done, isn't it? It's learned, it's analysed. We've had inquests, we've had specialists have gone and looked to see what has actually happened and analysed that.
As an engineer, one of the most interesting things that I've done is probabilistic safety assessment, which is specific to the nuclear industry. So it's a way to approach accident studies. You know, you analyze around 300 major accident sequences, and you identify and which are the most critical components, what are the most important sequences to be taken into account. And so you have all of these new methods, new engineering methods that are being developed in the nuclear industry. At
Mm,
first it was being inspired by more old industry methods like the car industry or the aviation industry, but now it has a life of its own, the
yeah,
engineering side of it. So
yeah.
it's a great industry with great standards of safety. That's my take on it.
In the 80s, when I worked at the power station,
Mm.
we had a little film badge. So we had to wear a film badge with different layers of lead inside to show you what radiation you'd been exposed to. So everyone wore this film badge, and that film badge was the only thing that could let you in to the reactor side. You had to put it in a machine, and then the machine would let you in. So that was one. So measurement and analysis was going on all the time. Um, we had ongoing routines training, and I would say once a month we practiced evacuations and different tests. So safety was absolute top of our list regarding what we had to do. You know, we still, it was very difficult working in that industry because we, we didn't have the gloves, for instance, that we have today.
Mm-hmm.
So we used to just have like cotton gloves, and it used to be really hard. You end up ripping them off to try and get to we have little fine. A lot of that's changed. I'm going back to the 80s one with that, but safety was very, very high on our list. It really was. I'm gonna
That's
I'm gonna jump onto something because I'm conscious that this is going to be the longest podcast ever because this is my subject. I really, like talking about it. Just for the interest of the audience. So I was working that night just after the Chernobyl incident,
mhm.
and though I was an electrician, we was asked to go and do readings around the perimeters to check what our radiation and contamination levels that increased 20 times because the weather had changed, and that's the only thing. The weather had changed, got cloudy, and it rained in the UK. So we had to measure all our energy, and it increased 20 times our levels. Unbelievable.
Unbelievable. But that's why it's important to measure,
Exactly. We
to
wouldn't have
take
known that
action.
otherwise. So, Mario, look, I really appreciate what you've been saying here, but I'm going to put you on the spot. This isn't putting you on the spot. I'm just opening up some more questions, I'm sure. Is there anything you can give back to our industry today from what we've been talking about here as a takeaway for our experts listening to this?
It's a great question, Paul. I think one of the most important things today about nuclear is to be informed, to look for the truth, which is hard to find
Hmm.
nowadays. But international organizations and businesses are trying their best, to put pedagogic, content that is informative, that can be understood by people that do not have a physics master's degree. So put the effort to try to understand this key key technology that is going to be really important for the next years. And for those students that one day can listen to this podcast, I think there's a lot of opportunities for you because, as we said during the podcast, there's a huge spectrum of knowledge, of competence that goes into nuclear.
Yeah.
So it's a really fun industry. Let's say it like that.
Unbelievable. Yeah, you're right. And so I was talking all this experience. I'm talking, I was 18 now. Then
Incredible.
I'm now 60 years of age. So the memories of nuclear power and what I learned now will never be erased from my memories. I've got really fond memories of it, driving through protesters and having protesters come to stop us from generating. It's such an exciting industry to work in, because of that knowledge base as well. And as I say, it never erases from your mind. You always go back to it. I'm sure.
That's really great to hear.
Brilliant. So, how old are you now, Mario? If you don't mind me asking.
I'm 28 years of age.
Brilliant. So we've got probably another 32 years of Mario in this industry. Yeah, please.
It would be my pleasure to be here still.
Excellent. And to start building that the first nuclear reactor in Honduras. Yeah.
Hopefully, and we'll do a podcast from Honduras.
Yes. Unbelievable. I'll come over and maybe cut the ribbon for you. Yeah.
It would be my
But just
pleasure.
make sure that I'm 65 then and not
I'll have to
105.
hurry up. I'll do my best.
Brilliant. Mario, thank you very much. And you know what? It's been great because I've gone back in time and talked about one of my favorite subjects. So thank you for, me personally. And please, you and your family, stay safe in these times.
Thank you very much, Paul.
Thank you.